Hello, I'm Justin Trenner. I'm the head of QA Vector Research and I'm responsible for QA Vector Analytics, our unique, innovative way of measuring quality across the software development lifecycle. I used to be responsible on a business level for technology development, and I never had a good way of proving return on investment in quality specifically. Return on investment was something that was demanded of me to show the value of the software, the value of the business, but how could I show the value of the investment in quality? And that's even more difficult now that quality is embedded in DevOps life cycles as much as put into separate waterfall sections of development. How do we know that we're doing the right amount to deliver adequate quality? We don't want the perfect to be the enemy of the good or will never deliver, but we don't want expensive software failures where we haven't put enough effort into quality. So what's the right amount? How do we compare to our peers? How do we compare to best practice across the industry and indeed across different projects in similar areas over different timeframes? How do we show that we are delivering quality compliance to our regulator? These are some of the problems that we are aiming to solve with QA Vector Analytics. And I'm delighted that we have the support and collaboration of the Bank of England in developing this program. We focused on macro issues. We focused on timeliness of application deliveries, defect escape ratios, the effort put into quality elements such as QA and testing and remediation of defects. And we've created some algorithms to analyze and compare in a very simply understood manner. I'm going to illustrate just a couple of things that we've learned so far. This is all based on real data. It's a limited sample set from the half dozen institutions who've kindly collaborated with us in developing this. We can see that there's a fairly narrow range of staff and staff time where it's a DevOps environment allocated to QA as a proportion of development, but a much wider spend variation, which suggests different levels of staff, very wide variation on the amount that's insourced and outsourced, but which models are the most effective? For that, we need to drill down to specific projects. This is aggregated data across different groups of projects, and we can see, reassuringly, defect escape ratios for our payments projects are very low. Payments are not going to the wrong place. And that's based on an average level of effort on QA and a slightly above average level of effort, always on these charts, a higher percentage of better scores, so more effort on remediation. Is that money being spent as wisely as on global markets projects where we accept a higher defect escape ratio and we have to spend more effort putting them right, perhaps in the rush to get real-time projects out? Or compliance projects where we have a low defect escape ratio, we perhaps put greater effort into QA and therefore are rewarded with less effort on remediation. Well, we often hear the trade-off between quality, cost, and speed. We don't see that in our data. You can see that for our compliance projects, we get a really good balance, apparently, of quality, cost, and speed. We put a little bit more into the quality and the speed, and the cost on our waterfall projects, but perhaps they go a little more slowly. And interestingly, they appear to outperform our Agile projects in our sample set. One of the reasons for that is switching to Agile doesn't make your developers good testers. And we often see a high defect escape ratio, often minor defects that are expensive to put right and cause significant projects delay as we move to Agile. So there's a learning point there of how you move to Agile. It doesn't invalidate the move, it just says, think about how you retrain and reskill some of your engineers to be effective testers and to look for the detail that often the old waterfall process would have teased out for them. So we want to reduce this, and we have reduced this to very clear scores. Very simple scores, overall quality scores, a ratio of the amount spent on quality-specific elements such as QA and remediation as a proportion of development, and then an overall outcome score, which is the efficiency, the amount of bang for your buck on quality you're getting, an ROI proxy, if you will. And if you remember back to our payments projects, which appeared to be very low defect escape and average QA and effort and average slightly above average remediation, well, in fact, not so efficient, because the way that we get rid of those defects is by spending a reasonable amount of money, and the result is that we don't consider it such a great quality outcome. By contrast, those compliance projects seem to be better balanced, and at the moment the mature waterfall projects seem to be reasonably well balanced in our database. There are business takeaways, not so much on this macro level, but when we break it down project by project for the people that we've been working with, validating elements of their operating model, suggesting that the projects using one operating model are more effective than those using others, showing that the changes that have recently been implemented in some cases have been effective, and for others, recent changes are only halfway there, and where the quality subject matter expert needs to look and persuade and get support for a slight change in training. We're gathering very simple data, and if you want to do a proof of concept with us, we'll take your estimated data for the key elements, and we'll then return you an entirely free proof of concept to enable you to justify over time making the data you gather more accurate and the effort, putting that effort into it, and signing up for our production service. If you'd like to know more, we'll do everything under a confidentiality agreement, and please contact me directly or contact us via the stand. Thanks for your time.